But what could possibly cause the expansion of space to accelerate like this on the largest scales of the universe? It starts with a deceptively simple question. Why is our universe expanding? One of the first things you might learn in a physics class is that gravity is an attractive force between two objects, whose strength is proportional to each of their masses. But if we zoom out further, this gravitational attraction begins to act in reverse, causing galaxy clusters to accelerate away from each other rather than drawing each other in. So, what's going on here? Einstein's theory of general relativity gives us a lens through which we can understand this strange behavior. In general relativity, space isn't just some background in which other things can move around. Instead, space itself can stretch and warp and evolve over time. Einstein showed that in this framework, gravity is no longer a force, but rather a distortion of an object's inertial path in a dynamical spacetime. This means what we observe as a repulsive force between galaxy clusters should really be thought of as an accelerated stretching of the space between them. But what could possibly cause the expansion of space to accelerate like this on the largest scales of the universe? However, conceivably, if you were somehow to set the values of this equation so that pressure was negative and greater than the positive energy density, that minus sign would cause the whole thing to flip, and you would accelerate the stretching of space. In effect, you would end up with a volume of space filled with a kind of antigravity, a dark energy. If dark energy was some kind of field that pushed away not just other magnets, but everything, then this would match what we see the universe doing. Vacuum itself having dark energy and enough of it to slowly, very gently push the universe apart.